This is number 7, right, Devin? All right, you are given OM is congruent to ER, and you're given ME is congruent to RO. And you have to prove. Do you see how they didn't tell you to prove triangles congruent? They just were choosing pieces of those triangles. All right. Looking at the picture, they've already marked everything they've given you. But that's not enough to prove triangles congruent. What else do we need besides this? A third side. Where is it? In the center. Okay. So what is this going to be? Side, side, side. You see, everything in the given is congruence. So I'm not going to start with given. All right? I only put stuff in given that's not congruence. So you just told me side, side, side. So now we're going to go through and we're going to justify each pair of sides. Did I give away any homework? Travis, you gave me the sheet, right? Yesterday. I haven't done those yet. Let's do this again. Maybe. There we go. Hope, not here. Samantha, interested? Okay. So Samantha's going to be a recorder. Here we go. I need one pair of sides justified. And the person that's going to tell me that is going to be Samantha. You already have a homework pass. Congratulations. Name a pair of sides. ME is congruent to, okay, now if you do M between the 1 and the 2, and then go to E, where do you have to go first? Yeah. And what's that reason? Given. All right, there is one set. All right, next set goes to Devin. Okay, and why is OE congruent to OE? Reflexive. Are you seeing the reflexive quicker? Yes, no? They share a side. That's why we did reflexive. All right. Third pair of sides goes to Harper.
MO and RE.
MO is congruent to RE. Nice. And why is that? Because it's given. All right, we have justified all 3 parts. We should be able to conclude with that statement now. Devin, what is this part going to say? Not yet. Triangle. Triangle. MOE is congruent to triangle. Okay, M to O. So, hold on, I got to think through this. M single double. So we've got to go R. We went along the single. So isn't it going to be REO? But we did, yeah. So REO, and what's that reason? It's the combos. Whenever you do triangles congruent, it's right. This statement, triangle congruent to triangle, will always be one of your combos. All right, now we're ready for this last statement. Angle M is congruent to angle R. And in order to do that, I need to know that reason, and that reason goes to Sydney. Corresponding parts of congruent triangles are congruent. All right, yes. 7. All right, so I don't know how this is going to appear on the EOC, okay? So I think what I'm going to do with you all, depending on how they do it, CPCTC is another way to write this. Corresponding C, parts P, congruent C, triangle T, congruent C. I don't want this alone, because if this is all you tell me, you'll never remember what this means. So I need to see corresponding parts of congruent triangles are congruent. Then you can put that in parentheses. What I want to make sure that you understand is this step must come first, because this statement is assuming you have what? Congruent triangles. So that's why this comes before this. Notice, did they tell you you had to do that? No, they did not. You had to know that. All right. Any other questions on your homework? 9. Okay, so number 9, they've given us 2 congruences to start. The book was much kinder than I was. So number 9, we are given angle SPT is congruent to angle OPT. And we're given segment SP is congruent to segment OP. And it almost looks like a little arrow here. Something along those lines. Notice I didn't draw my diagram to scale. So we've got O, P, S, and T. All right, so we're going to prove that we have angle S is congruent to angle O. So let's mark what we've been given. SPT, that would be this angle, is congruent to OPT. You're given SP is congruent to OP. All right, with those marked, notice I have used each part of my given. Kayla, I've used this already. I've used this already. What can you pick from the picture? Yes. All right. So with that, we should be able to see a combo to start our proof. The combo, Kaylee, what is it? Good job. Side angle side. So everything in my given is congruent, so I will not start per se with all of that. We've got side, angle, side. So number 1, this is statements. This is reasons or justifications. They could use either word. I need to know, I need a pair of sides. Nick? SP is congruent to OP. Why? Are they the same segment? When you cut an angle in half, will you get 2 equal segments? In the given, were you given a segment bisector? What were you given in the given? You were given this, correct? Okay. See, they've made it too easy. You're used to hard. All right. So after this, I need a pair of angles. What are my angles, Sydney? SPT is congruent to angle OPT. Why? It's also given. All right, so my 2 givens in my proof now are used. So we have to go for what we have not mentioned. Travis, what have we not mentioned? TP is congruent to PTP. What reason? Excellent. All right, so what is my next step? Sydney?
Triangle.
Yes.
SPT.
SPT. All right, nice correspondence of the vertices. What is that reason? Right. All right, now we did all of that for our very last statement reason. What will that last statement reason be, Eric?
Angle S equals angle O.
Yes. Angle S is congruent to angle O. Why? Okay, it starts with the C.
corresponding.
Corresponding what?
Um,
Next one is P.
perpendicular.
Okay, do you have notes from yesterday?
Probably not.
You didn't take notes yesterday?
No.
Go look.
No.
Okay, so where are you going to take notes today? Okay, so will you be able to find them?
Yeah.
Are you on a geometry page?
Yeah.
Okay, so it's called corresponding, write this down, corresponding parts of congruent triangles are congruent. Do you see S corresponds to O? Because these triangles are congruent, that means there's 3 pairs of congruent angles, there's 3 pairs of congruent sides, also known as CPTCP. Corresponding parts, congruent triangles. Oh, did that wrong. I think it's so much easier just to write that. Corresponding parts of congruent triangles congruent. All right, 9's finished. Any other questions? Ooh, let's look at 16. 16 said, oh, now this is more like what I've been doing. All right, so I'm going to go to a new page. So on 16, we have a picture that you've seen a lot. All right, and they've told us or labeled it APCB. It's a P. CB. And what did they give us? This is 16. So up until this point, they've been very generous. Oh, by the way, this is line L. They've given us that line L is perpendicular to AB. They've told us that line L bisects something. Bisects AB. I think I labeled my triangle wrong. Did I label it wrong? Hopefully you have a picture on each problem. I did label it wrong. Okay, so this is actually C, and that is B. So fix your paper so you won't get confused. All right, anything else they gave us? And they said prove that PA is equal to PB. All right, we need to start marking our picture. So let's start marking it. What's one thing you can mark, Harper?
The perpendicular relationship between line L and segment AB.
All right, so these make these what?
90 degrees.
Okay.
Right.
So we've got right angles. We know those are equal. I don't know where we're going here. Kayla E., what else can you mark? Harper used that piece of information. PC is congruent to PC. All right, so we got another, that's good. And there's one last piece of information we need to mark. Devin? AC. And now what told you that, Devin? Well, yeah, it is a perpendicular bisector. They kind of separated it. They could have saved themselves time and just said perpendicular bisector. It would have been easy. All right, so these are my statements. These are my, I'll use justifications this time. These are my justifications. So step 1, why am I writing this stuff where I didn't do the given on the last one? Why am I writing this now?
It's not just congruence.
Because it's not congruence. We have to put this to establish this in our proof. So that's been given. All right, what combo proves these two triangles congruent? Travis? Excellent. So now we're going to do side. Let's see. Not quite. We will be doing side angle side. I think we need another step before this. So we've got side angle side set up for a minute. All right, step 2. All right, we drew boxes. McKenna, we drew boxes. What does that mean? What do those boxes mean? So we know that angle ACB and angle BC, that's P, ACP, sorry, that should be a P. ACP and BCP are right angles. How do we know this? Right, definition, perpendicular lines. All right, so now we're ready to fill in our side angle side. This is going to go to McKenna. Can you give us a side? PC is congruent to PC for what reason? Reflexive. All right, there's one side. Now we need our angles. Where are our angles that are equal? Jennifer? Which angles are marked? Well, okay, but we have to use 3 letters because there's 2 angles there. A what? Okay, that's a P, there's no E. Do you want to get closer? Do you have glasses? So I need to move you up front. Would be beneficial? MJ, would you switch places with Jennifer for the moment? For today, take your stuff. Thank you. Okay, so tell me which angles are congruent. Pardon? AC. Okay, ACB is a straight line. What forms this box? A, C. Where does my little dot have to go to trace that side? I've traced one side of my angle. Well, where does it have to go? Yes, so what is that? Okay. Does this help? Does that help? Okay. ACP. All right, so this is going to be angle ACP must be congruent to what? BCP. All right, and you did a nice job on corresponding your vertices. You started with A, which means you had to start with B. Now, why is that true? What do we know? What are they equal? There's a box. Okay, so definition of what? Yes, definition of right angles. All right, I need another side. All right, so who's going to give me the sides? Carlin, what are my sides? AC is congruent to BC. Why? What? Well, it's not given in this form. It has to look exactly like this to be given. But something in the given told us that. What kind of bisects? Because they gave us perpendicular here and bisects there, I'll give it to you. I would accept definition of perpendicular bisector. What else would I have accepted? Segment bisector. All right, so now that we've justified our combo, what is my next step, Carlin? Yes, can you see? ACP is congruent to triangle BCP. What's the reason? side, angle, side. And then last but not least, how do I go to the very last part? MJ? I have to prove PA equals PB. How do I go there? Write it, PA equals PBY. Why? Where are your notes from yesterday? Where's your book? It's the one thing we learned yesterday. Okay, I want you to get up and go talk to Eric. Your buddy wrote it. Go see. No, go see. See, you're moving, you're seeing. So that's two senses. You're going to learn it more. Corresponding parts of congruent triangles are, I'm going to say equal this time because I've got an equal sign. I don't think if they get that picky, they'll make sure that it's a fill in the blank that you can do. All right, any other? Okay, so I'm going to stop at the moment on the homework, and I'm going to go and start on what we're going to do today. Again, we've already done section 4.6 is hypotenuse leg. I've already incorporated hypotenuse leg into the lessons, so we've already done that piece. But this is what they're doing today. This is section 4.7. And I didn't have any separate notes for section 4.7. In fact, I wasn't going to go there, but we decided to do that when we sat down and planned together as a department. Okay, how does this picture look different than what we've had in the past? How does it look different? Yeah, it's more complicated. So I say, do you see, oh, there should be another. Let's make this F. Do you see that there's a triangle ABF and there's a triangle EDF? Do you see those two? Those most likely are congruent. And it's possible that they may have you work with those. But then, do you see triangle ACD? Where's ACD? It's that great big one. Do you see that one? Is there one that matches it? Which is it? E corresponds to A. C corresponds, and then B. So I will try to trace that in another color. The only problem when I use a highlighter, the colors mix. So if I've got, there's this triangle. Do you see those two? It's possible that you're working with those two triangles. Now what's really special here that you have not had before, if I want to work with these two big triangles, there is a reflexive here that you've never seen before. Look at this. What angle is this? Angle C. Is angle C in the yellow triangle? Is all of C in the pink triangle? You see, in this problem, you would have reflexive angles. Now, they would have to, one option that you can do if you don't like that they look all on top of each other, could you separate these two triangles if you had to work with them? There's that one. Could you? On your paper? Yes, you could. Now, you would have to realize you'll lose, this is C, this is D, this is E, this is C, and this is B. You'll lose the fact that C is the same, but angle C is congruent to angle C. So AC is congruent to EC, AD corresponds to EB, CD corresponds to CB. All right. So I think what we're going to do now is I'm going to give you a proof, or we're going to do a proof with a diagram that looks a bit crazy. All right, so here is our diagram. See that triangle? See that triangle? Obviously, they're not congruent, but you're going to prove them congruent because my diagrams is not drawn to scale. All right, so we have, and there's several triangles here, aren't there? Z, W, Y, X. Now, the fact that they didn't give you a point here means you're not going to be using those two. All right, so what have you been given? You have been given that angle ZXW is congruent to angle YWX. You have been given angle ZWX is congruent to angle YXW. And you are supposed to prove that ZW is congruent to X or YX. I think I just told you the exact same angles. This is ZXW, YWX. Okay. What do they share? There's something they share. What do they share? WX. Everybody see that side? All right. So I think what I'm going to do is I'm going to take these two triangles. Now, they have to be together to see the shared segment. But I think it's going to be easier if I pull these apart. Would you agree? So what I've done is I've just kind of stretched them over. This is W, this is Z, and this is X, where this is W, this is Y, and this is X. So where is, McKenna, angle ZXW? It's on the left triangle, top, left, or right? It's that ZXW. Z. Do I go down this way or down this way? Next vertex is X. I go to the right. ZXW. So this angle is going to be congruent to what? YWX. Now we can't say W because it came from this picture. So ZXW would be this angle here if we did not separate them. And then YWX would be this one here. Those are the same angles I've just marked. All right. How do I mark the next set of angles? Hope is not here. Tommy? This is my next set. Z, W, X. Where is that? So ZWX, and where is YXW? On the right. All right. If I look in this picture, ZWX is this great big angle. And then YXW is this great big angle. Do you see where that gets to be a little bit confusing? So we got the fat angle, and the little angle. All right. You all identified a side about 2 minutes ago. Tell me what side was that? WX is indeed congruent to WX. So if this is too complicated to see, I have separated them. I would put this picture and those pictures on your paper so you can see the reflexive. All right, so as we start to work with this proof, what is the combo, Kayla? If I wanted to, I would have to try to focus on one triangle, and I would see in this triangle, big angle, side, little angle. So it is nothing has changed from yesterday except the diagrams have gotten a bit convoluted. So we've got statements, and we've got justifications. And Kayla just told us, what did you tell us, Kayla? Angle, side, angle. All right, so I need someone to name a pair of angles. And that's going to be Nick. What's one pair of angles? Angle ZXW. Okay, Y. ZXW, those are the first ones we marked. Y. Yes, it was given. All right, I need my segment. What segment is congruent? Karen? WX, I should make that bigger, is congruent to WXY. Excellent. Reflexive. All right, I need another pair of angles. Where is my other pair of angles? Kayla E? Oh, what did I just do? I don't know. Okay. Another pair of angles? 3. Angle ZWX, that's the double, is congruent to YXW. Why? Pardon? No, look at the top. Right. This double, you see those double marks? Look in your original picture. Are they the same angle? Or are they two different angles? If they're the same, you'd only see one pair of double marks. You with me? Yeah, they're different. All right, but it is given. All right, with that said, what would my next step be? Nick? Triangle what? ZWX. Good. Why? Right. Angle, side, angle. All right. And my last step goes to Caitlin. What will our last step be? Okay. So you said ZW is congruent to YX. Why? Yes. What do you think? What made this easy? Separating those triangles, yeah. Otherwise, it's hard to see. It's hard to see if you don't separate them. So what is the key to being successful in tonight's homework? Separating your triangles. All right, before you pack up, are there any, we got 7 minutes. Are there any other questions on the homework you'd like to go over? Caitlin? 15? So we're back on 4-4. And 15 is more like the last problems I gave, last 2 worksheets. On 15, you have been given something. You have been given that BA is congruent to BC. You've been given BD bisects angle ABC. And you are to prove several things. That BD is perpendicular to AC, and that BD bisects, they've really stepped this one up, AC. All right, and our picture looks like this. All right. And I don't know what my letters were. Letters are A, B, C, D. A, B, C, D. Now they gave us this side congruent to this side. And what else do we know is congruent? Tommy, I've already used this piece of information. What else is congruent in that picture? Correct. BD is congruent to BD by reflexive. And that didn't require anything up top. Kayla, what's next? Okay, you have to use this. That's correct. What does this mean? What does an angle bisector do? So where are your two equal angles? At B. In other words, this angle is going to be congruent to that angle. All right, so with that said, what is my combo going to be? My combo goes to Brittany.
What was the question?
What's the combo?
Side.
Side angle, side. Now notice I'm beginning with BD bisects angle ABC given because there's no congruence there. Now, Brittany just told us side angle, side. Notice at this point, and only now will I bring in my BA is congruent to BC. And that's also given, but it also takes care of one of our sides. All right, then when we go to our angles, we're going to have to say angle ABD is congruent to angle CBD, and that is because definition of an angle bisector. Our third side, or second side, is going to be BD is congruent to BD. Why? Reflexive. All right. All of this together says that triangle ABD is congruent to triangle CBD. Why? All right. Now, this is where we need to prove this bisects. If something bisects AC, what must be true? For this to bisect, what must be true? AD must equal DC. So we're going to say that AD is congruent to DCD, and that's by corresponding parts of congruent triangles are congruent. Now, if these segments are congruent, what does that mean BD must have done to that segment? So now we're going to say BD bisects segment AC by definition of a segment bisector. So what we've done is we've kind of gone, normally we're given the bisector and we get the congruent pieces, we're going backwards. So now what do I know about angle 1 and angle 2 if those triangles are congruent? Why must they be congruent? Corresponding parts. Corresponding parts, congruent triangles are congruent. All right, and so now what are they? What kind of angles must 1 and 2 be? Angle 1 and angle 2 are 90. And I think, what do we know about linear pair angles or supplementary? Does that make sense? If linear pair angles are supplementary and they're congruent, don't they both have to be 90? So why is AC perpendicular to BD? What have we established? Definition of perpendicular lines. We've established our right angles. That was a nasty one. All right, so on your way out, you'll put your homework on this desk. Caitlin. Put what? Whenever you have congruent, whenever you say triangle congruent to triangle, it's a combo. The reason will always be a combo. And it always has to go, this always has to go before this statement because you're assuming congruent triangles. Oh, because there's no congruence in this statement. All right, no congruence. So I have to put it in my proof, so I'm going to start at the top. And so once I have that, then I'm going to do my side angle side. Because whatever they give us must be in the proof, but that is not going to help us here to justify. That gave us this. That had to come before this. Oh, and wait a minute. Oh, wonderful. You are awesome.